Thank you all for making it here. Good afternoon, everyone. I'm Francis. I'm a senior product manager here at Skydio, and I work on our high accuracy solutions. So today I'm going to give you a brief overview before we turn it over to the panel, and we'll be talking a bit more about RTK PPK technologies and answer a bunch of questions from you. So I'm excited to talk about a solution that we'll be bringing to market very soon. And before we dive into it, just a quick show of hands. How many of you are surveyors or use surveying as part of your everyday jobs? Okay. I promise I won't pick on anybody. Quite a few hands, so I feel like I don't really need to preach to the choir here. A lot of you are familiar with these use cases. You understand the importance of being extremely accurate, whether it be critical infrastructure or construction of houses or other buildings. You need to be within tolerances, within really tight tolerances, or even if you're in public safety and trying to collect evidence, you need to make sure that you're as accurate as can be. And oftentimes that means 1/10 of a foot or 3 centimeters if you use metric. So today we'll talk about Skydio X10 with the RTK PPK attachment. It uses the same technology as the RTK rovers that you have currently. And what that lets you do is get from inaccurate GPS estimates to receiving corrections from a base station or some other correction source and get down to 1/10 of a foot accuracy. And you can do this using a base station, using a CORS network, using existing infrastructure that you already use, and also take this information and process it using the same tools that you're familiar with today. So use just an attachment. Everything else is stuff that you're already familiar with, and it just fits in your workflow. We've talked about this before as a concept, but now it's reality. It's here. And if you're a beta customer, you'll get to play with this before the end of this year. And what can you do with this? There are 3 primary use cases that we're targeting. So we're looking at monitoring progress. This is especially useful in construction. You can estimate volumes very accurately, which helps our construction customers, but our customers in mining and utilities as well. And then, of course, there's also always the possibility of measuring distances within your reconstructions. And this is especially important for our public safety customers. So we'll talk about each of these one by one. First one is monitoring progress. So a lot of our customers today, they actually use Skydio images, and they try to monitor progress by eyeballing it. So you look at images today and try to figure out if things are in the right place, if things are progressing along. But with the georeferenced accuracy of an RTK solution, with georeferenced photogrammetry, what you can do is you can overlay your BIM models, you can overlay your construction data, and then see if things are according to spec. And once you have this, you can make sure that you're always on track. You can identify mistakes before they become so expensive. And by that, you can save on a lot of costs. So it's a powerful new way to catch deviations early and help prevent cost overruns. And here you can see some data that Ted here was very gracious to share with us. This is from Maple in Canada. They're a general contractor construction company. And so they were able to use the X10 and overlay their BIM data and identify these deviations very quickly. Another capability that's unlocked by RTK is estimating volumetric changes over time, which is important in construction, but also in mining and utilities. So what this lets you do is you define a boundary, and that gives you a volumetric estimate very quickly. And because the data is so accurate, you can use this for things like verifying how much earth has been moved before you make that payment to your contractor. In mining and utilities, you can use this to accurately estimate your stockpile volumes, and that helps you with future planning and order. So lots of different things that you can do with this to improve your workflows in general. And the same solution can also be used in a bunch of other use cases. So we've heard about beach nourishment immediately after a hurricane. That's a pretty interesting use case. And you can also do avalanche monitoring with this sort of stuff when you can estimate snow volumes. And last but not least, measuring distances. This is very important for our public safety customers who want to get a very accurate reconstruction of an accident scene. They want to collect all of this data, make sure that the total station data that they collect can be overlaid perfectly on all of this, and it can actually be presented to a court as evidence. And so accidents are always unfortunate, but people still, they're tasked with reconstructing the scene as quickly as possible and getting this out of the way so traffic can continue flowing in order to let people keep moving and to make sure that there are no more subsequent accidents. And so Skydio X10 will be able to help with this. So what makes all of this possible? We've got best-in-class sensors for all of your missions. We've got industry-leading rolling shutter correction. Try saying that 3 times. So this is something that we're really proud of and is something that differentiates us from the rest of the industry. With the VT300L sensor that we have on there, despite the lack of a mechanical shutter, we're able to achieve highly accurate reconstructions through this rolling shutter correction. And lastly, we're partnering with the providers of a lot of powerful software. Some of them are here today. So you'll hear later from James from Drone Deploy. We're integrating with TBC. We're integrating with Pix4D. So we have a lot of partnerships that are ongoing with these companies to make sure that our new camera models, the way we do rolling shutter corrections, all of these are accounted for. So you don't have to take any extra steps to get from data collection to the actual insights that you care about. And for the first time today, we're going to show you the results of some of the internal testing that we did with our rolling shutter correction. So this is just looking at horizontal RMS errors. And you see the orange bars that are before we applied rolling shutter correction. So we collected this data. The same rolling shutter correction that runs on board on our drone was then applied in post-processing. And you're able to see that even without any GCPs, this is with checkpoints only, we got really, really close to 3 centimeters in almost all of our cases. And that gave us the confidence to go ahead and build a solution. And you can see the same thing on the vertical axis as well. Again, orange before applying rolling shutter correction, blue is after, and that green line over there is the target. And this is all results from very early in the development cycle, so we've actually made a lot of changes since then, and our results today are going to be a lot better. And beyond that, it integrates with the tools that you already use. So we talked about Drone Deploy, Pix4D, TBC, Bentley, and there are a lot more that are not included on this list. And then we're also compatible with a bunch of correction sources. So you have your own base stations that you can bring. You can bring a Trimble. You can bring your MLID. And then you can also connect to CORS networks. You can connect to correction services out there. So Point One or a SwiftNav or Hexagon SmartNet. So a lot of these have already been validated. And we're continuing to validate a whole ecosystem of a bunch of different tools that you could be using today. And you can also see some more data that we collected over the last few weeks. So this is data that was collected by a customer. This is Iowa, so they were using the Iowa State Plane Coordinate System. And so you have this reconstruction that they did in GNext. And these customers, they primarily use Pix4D and Esri. So they were also able to provide accuracy targets, accuracy validation here. So you can see the RMS values of the X, Y, and Z separately. And that green chart over there is that 3 centimeter target. They used a bunch of GCPs for this, but we've also done a lot of tests without any GCPs. This is another zoomed in version of the same thing. And as I hand over to the panel so everyone can get seated here, if you want to take a look, you can pull out your phones now. You can scan these QR codes and look at these 3D models on your phones by yourselves. Yeah, thank you.
Great. Well, thank you, Francis, for that awesome presentation. Before we go to the panel, just some quick intros. I'm happy to start. So I'm the moderator for this panel. My name is Gagan Kanwar. I lead tech partnerships at Skydio. Very excited to be here with all of you talking about high accuracy measurements using Skydio X10s. And also, a lot of the partners that we're referencing here are people that I work with directly, and again, excited to also have that opportunity to have them on the stage with us. So with that said, I will hand it off to Aaron for intros, and let's keep maybe going on the line.
Sure. Aaron Chamberlain, California Department of Transportation. You drove through our road work on the way here. All that work is being done by our division, so we Caltrans is 23,000 employees. We have $14 billion under construction currently, about 2,300 projects. So I believe we're the largest. Texas is going to get mad at me if I say that, but we're the largest DOT in the country right now. So a lot of work going on out there.
My name's James Pipe. I run the product and design teams at Drone to Play. I've been at Drone to Play for the last 8 years, and we work across many different industries. And I'm excited to speak about high accuracy data today. It's very important to all of our customers.
I'm Ted. I'm from Canada, and I bought my first drone in 2017, and I've just been using it for services. So I own a small company, and typically you can find me out in the field collecting data, and I'm also a huge photogrammetry nerd. So somehow I find myself on this stage talking to you guys about that as well.
And I'm Francis. I'm a senior product manager here at Skydio, and I lead our RTK solution on the product side.
Great, well, thank you. So the first question, and the way we'll do this is we have questions for all the panelists, we have questions for specific panelists, and then we'll have audience questions as well. So this first question is really for all of our panelists, and it's basically, what are the big problems that are out there for high accuracy, and how do you see PPK and RTK helping address those problems broadly for the industry, and then what are the implications of that for the kind of stuff you're doing individually with your customers or for your business?
Who's going first, me?
Actually, why don't we start with Ted?
Sure. I think one of the biggest bottlenecks is just understanding all of the concepts that go into getting accuracy out of photos. It's not a perfect science. It's a mixture of art and science. And a lot of these blunders can happen very easily. They can happen in the field, and they're not really recoverable afterwards. So it takes time, and it takes quite a bit of trial and error to figure it out. And I think that's one of those things that we can talk about accuracy, but really that accuracy happens out in the field, and it happens in an office with a human in front of a screen doing a lot of clicking, and all of those things have to work together very well for it to happen consistently.
I'll start with one word, and that's datums. Knowing which datum has been used to collect the data and which datum you're going to be using that data in is the biggest problem. And the second is trust. And can I trust this data? Especially if the data's already been processed and you're downstream of it. Is this actually good data? Can I make a measurement? It's extremely difficult to qualify as a professional surveyor in the US for good reason. It's a very hard problem. And it's something that, through a bunch of new technology, I'm very excited to see becoming easier and easier to solve.
Sure. I would say, well, adding to both of those, I would actually say the standardization piece, right? So we have really good ASPRS standards. Anybody familiar with what I'm talking about? Or am I just throwing out random acronyms? Yes? Not if you're here. Okay, so we got ASPRS standards, right? But they don't necessarily work great for highway construction, particularly linear corridors. Not great, right? So one thing that actually California and Alaska DOT are going to be leading an effort on is a pooled fund study for structure for motion photogrammetry standards, for bridge inspection standards, basically the gambit of all across the board for, at least in our industry, for highway-based standards, so that we can actually have a base product of, okay, what do I need for construction inspection? Do I need 2 centimeter accuracy? Do I need 4 centimeter? For a bridge, if I'm doing bridges, right? So ASPRS standards are great for nadir imagery. What do I do when it comes to a bridge? Okay, how many GCPs do I need on the Bay Bridge to be able to recreate an active model? Nobody really knows the answer to that question, so we're hoping to be able to tackle some of that stuff with that pooled fund. So that's going to be starting here in about 3 or 4 months, and it's going to take about 5 years. But we do have assurances from Federal Highway Administration that they're going to be backing our results from that pooled fund study.
Cool. Right.
Yeah, I agree with what most of the panelists here have said. I think it is ultimately a very complex workflow, and you throw a drone in there, you're capturing something from 400 feet up in the air, 300 feet up in the air. You have the precision of an RTK up there, but even like a 0.5% change in your focal length that you don't account for, that means your models are going to be completely inaccurate. So that's the level of precision in engineering that's needed. And then there's a very big role of GIS expertise as well. So like you mentioned, having a bunch of different datums, knowing what datum you were receiving corrections in, what datum you're processing everything in, and doing all of that and having the knowledge to do all of that in the right way is also something that you need to make sure you have there before you can trust those results.
And that's actually a good segue for the next question, Francis, which is also for you. Can you walk us through the development of Skydio X10's RTK and PPK module, but also the technology more broadly? And what were some of the key considerations for you as you were working with the engineering team and our customers to build those capabilities?
So, like the title of this talk, it's about accuracy, but zooming out, it's about a lot more than that. One of the first things that we did when we were developing the solution was go out and spend time with customers to see how we were doing these things. And one visit was, in fact, with Aaron here. And despite how charming and insightful you can be, the best part of that day was getting back in the car and not having to deal with 115-degree heat and no shade.
Hey, that's life.
And so I think
to California.
Even for the most sturdy and outdoorsy people in this room, I think if you were given the chance to simplify this process and spend your time doing other more valuable things instead of just collecting data, you would take it. And so that's been the guiding principle for us developing this product. And thinking of the considerations, I guess there are 3 key ways that we can do this. The first is making sure that your flight setup is super easy and the actual flight itself is super easy. So this involves bringing in your project data, bringing in your construction data so you can plan despite the inaccuracies of whatever map layer may be present. The second is making sure that you're not making mistakes out there in the field, or when you are making mistakes, those are super obvious. So even with the beta product, we do things like fetching and pre-populating a mount point list. So if a single spelling mistake isn't ruining your whole day that day, we try to make it very obvious when your connection drops or something else untoward happens. You can see distances to base stations and things like that. And the last piece is, of course, integration. You have to take all of this and you have to pass it through powerful engines like a drone deploy or a TBC to get those results. And Gagan and his team have been very fundamental in helping us achieve that and establishing these partnerships to make those workflows easy. And that's just scratching the surface with beta. Beyond beta, there are other obvious things. We will have RTK solutions that are working on remote flight tech on the X10 dock. And so there are, we know not all of your terrains are going to be flat, so there's going to be terrain following, corridor capture, all sorts of new features that we will be building to make this whole process easier.
That's super interesting. Next question for Ted. Ted, having had early access to the RTK and PPK attachment, could you share kind of your testing process and what results you saw with that? And then how did this sort of early access influence your approach to precision mapping and what were your key findings there?
Yeah, well, when I first saw X10, I think it was almost a year ago, I was already a Skydio user. And if you followed my story on LinkedIn, I post a lot of videos. You can kind of see the progression of that and where I use Skydio vehicles. There's specific use cases that I was putting the S2 Plus in that no other drone could manage. Inspections specifically, and by the fact that it was completely able to function in a completely GNSS denied environment, like under a bridge. When I saw X10, we had an evolution of that, but then we also saw attachments. And my mind, when I saw the RTK attachment, first went to, holy cow, 3D scan with RTK or PPK, that's what I'm looking forward to, and that's what I wanted to test right away. But then there's also mapping, because now this drone that I had previously, the S2, where I would put that into situations that it did really well in, but I would maybe use another drone for mapping scenarios. The X10 I can use across the board, and so it's become really a multi-tool. And throughout my testing, that's the type of environments I'll put it through. I made a little video because I like to let the data kind of speak for itself. So we'll play that now. All right. So this was a building that I scan every year for the city I live in. And this year I did it with the X10, and past 3 years I've done it with S2. So I was able to PPK correct all of the image positions, and this is what I'm talking about. Having accurate priors or known positions before a reconstruction gets you this. This was 22,000 images. It took about 2 days, and then that camera was the next thing I was really excited about, the resolution bump. So you can see that play out. The other thing is having thermal there, always, capturing, plus RTK. Lets you do this. Combine a 3D model from the RGB, really detailed, but then you can texture that with thermal information. I put the X10 through a lot of different situations. I'm in Canada, so we see some interesting weather sometimes. Wind, dust. See here an example of volumetrics. I say something pretty provocative here, GCP-free volumes. Aaron might not agree with that, but this is a runway, and I've done a project like this before with an M300, and the one thing is that the X10 can fly really, really low and map, and other drones are typically limited by that minimum altitude. So I was able to get 2 millimeters on one battery. Makes this very feasible for larger scale inspections of this type. And it may not always be a runway, but it's there. And then the rolling shutter correction. This is just PPK'd images on ground control. And you can see that error. That blue circle is where the GPS position is. So you can see how far off we are, and we can see the error to GCP position here is about 1 centimeter horizontal and 3 to 4 vertical. Now that's GPS accuracy. You're not going to get better with your receiver anyways. But I've also put an X10 through other situations that are not RTK dependent, but again, it's that multi-tool aspect of it. That thermal camera I love, and I love that it's just there. That's one of the biggest bonuses. And of course, photogrammetry and 3D scans, why not do them indoors? Because you can. And why not throw it into drone deploy, because then I don't have to process it and spend any time. And you can see that the results are fantastic. Another more confined space, indoor 3D capture here as a time lapse. And another drone deploy reconstruction, really great textures. And again, that was about 10 minutes of flying, very, very quick, 400 photos. I love demoing the X10 when I'm around my friends. That's Adam. That was a booyah. And this was kind of interesting. This was actually Sunday before I came here, and I had some LiDAR GCP targets. They're a little interesting, but I couldn't find them. I didn't want to pull out the receiver to go and find the points and track it down, so I actually used X10 with a night sense on. And I would spot them in the air and then just let it hover over, and then I'd drive my truck over to that beacon. And it was also my work light when I needed to pull it out of the ground and put it back in the truck. So multi-tool. But yeah, I think that sums it up pretty well. Testing's still going because there's so much to test. And that's the beauty of photogrammetry and just working with the data. We don't really know everything that we can do with it yet. And use cases are popping up all the time.
Thank you, Ted. Next question is for James. James, how does the precision offered by RTK PPK help drone deploy offer more capabilities or better outcomes to customers?
Well, I was worried I was going to have to sell drone deploy, but thankfully I've got a team. I'll give you 3 examples. So one is DPR Construction, one of the largest GCs in the US. They have spun up quite recently an as-builting workflow for underground utilities. Scary stat, once every minute in the US, a construction crew hits an underground utility. It costs $30 billion, and 400 people die every year because of it. It's a huge problem. And the worst part is, often it's the same contractor who buried the thing that then hits it, right? And that's obviously also very embarrassing. It stops work on job sites. It causes huge problems for critical infrastructure. So that's, one workflow is just fly the drone all the time. Every time you're digging trenches, every time you're laying underground utilities, capture where they are, and the accuracy you're going to get from a drone like Skydio X10 with RTK or PPK is exactly what you need for that problem. Really, really awesome workflow. They have a digital dig board so that anytime anyone's going to dig, they first check the digital dig board, which is just drone deploy, and they can see their designs in there as well. And actually, if you press play on the video I've got here, you can see the other thing we can do is once those underground utilities have been modeled in their as-built position, you can import those into Drone Deploy as well and then just visualize them by making the ground transparent. And you can visualize them in 3D, so you can see how far below the surface they are and measure that as well. The second piece is comparison to design. So again, you can just pull in, visualize your data in the format that you use, and as a result, you can see piers underground, you can see the actual infrastructure itself, you can see what you're about to build, and you can have a look and see if things have been built in the right place. You saw it earlier with a 2D example of here's an overlay, but you can also do that in 3D. Again, the key point here is everything needs to be in the same datum, everything that you're ingesting, you need to know how it was measured. But then you can get these fantastic results. And then the third thing is topographic mapping and comparison over time. So measuring volumes change over time, measuring the amount of materials you're importing or exporting from a job site as well, and ultimately signing pay applications as a result of that data.
Thank you, James. Next question is for Aaron. So Aaron, from a transportation engineering perspective, how does the precision offered by RTK and PPK impact large-scale infrastructure projects? And could you share some examples of like how you would use those in real life?
I should have had a video. Apparently, I missed that memo, guys. What the heck? So I don't have a fancy visual for this, but anyway, we'll talk you through it. Yeah, so anyway, big infrastructure going on out here. I mean, you all drove through our work zone, right? How fun was that? And at 2 o'clock in the morning, it was still busy because they were out there paving. I know because I came in at 2 a.m. last night. Anyway, all this stuff that's happening out here is really important because we're spending billions of dollars, right? Of how many of you all live in California? So that's all your money, right? You're paying those taxes. You want us to be expending it properly. You want us to know where that stuff is, where all these utility lines are, where all our culverts. Right now, Caltrans is embarking on this big, kind of a bigger vision of anybody familiar with the term BIM, Building Information Modeling? Came out of Stanford. Previous to that, it was called VDC. Federal Highway Administration decided to call it BIM for I, so now we got a bunch of acronyms that all mean the same thing. Anyway, none of that process works, right? The big BIM push, right, is all involved in 3D modeling. 3D modeling, lots of attributes. We can't get to that level if we can't do the reality capture piece correctly. So that's fundamental to all of this whole BIM world working, is the reality capture data and the modeling capture data all come together in one interface so we can actually, now start to apply things like machine learning. We're still, I would say, really early in this process, but we're starting to see a lot of success with, not necessarily photogrammetry yet, but some of our LiDAR products being able to do auto feature extraction and then auto comparison. I think that those technologies are going to come very rapidly to some of the structure for motion photogrammetry products as well, where we can start to do automated inspections. So I don't have to send 3 guys that I can't afford to pay anymore. I mean, right now, any of our engineers in California, you want a job? We have 1,700 vacancies. So it's not a great time to be in our industry because we just can't get people to do things. So to be able to automate a lot of this is really going to be critical. That's why we're looking so forward to things like dock. So we have 3 dock systems of the older generation currently used right now on active construction projects right now. So there's one in Northern California, one in Ventura County, and one in San Diego. All those things are out collecting data on nearly a daily basis. But adding that PPK element to that is what's going to help us, again, build those digital as-builts and start to function for trying to alleviate some of those manual workflows that we have historically had that are, in some cases, still, I don't want to say this, but some of them are still paper-based, or at least PDF. But right, those are a lot of these manual workflows that we're doing. So really, this is going to take it from this, I still say paper-based workflows, or these form-based workflows, into a complete digital workflow where drone can go fly our job site, give me a report, hey, at the end of the week, hey, we moved 26,000 yards of dirt. Now I have a paper trail that goes with that. When I'm paying our contractor $600,000 and they have a dispute and say, oh, you owe me $700,000. Okay, well, let's go to the referee. Here's the data. I'll give you the data. This is what's, we're not going to have these arguments anymore. And frankly, those are a big component of what we do. I think Caltrans pays out about $500 million in construction claims every year between change orders and claims. So if we can reduce that even by 50%, we're saving the taxpayers a lot of money by using technology.
That's really interesting. So I think we're coming up to the last question here, and this one's, again, for all panelists. So I'll start with you on this, Francis. Looking ahead, where do you see the future of RTK, PPK technology? And what advancements or innovations are you most excited about? And actually, before you answer that, I think it might be helpful if we could just clarify for the audience quickly, what is the difference between PPK and RTK? And also, like, what are the use cases for PPK versus RTK?
Mm-hmm. Yeah, so the primary difference between RTK, which is real-time kinematic, and PPK, which is post-process kinematic, is the real-time aspect of it. So if you're using RTK, you're receiving those corrections in real time from a base station or some other correction source. Whereas with PPK, you're collecting all of that data on the correction source and then processing it later to try and achieve the same accuracy. So with these technologies, there is a big ecosystem of different players that are coming in and helping make this industry a little bit easier for people to understand and work with. So in general, there is this trend of the industry moving towards an easy button of sorts, where you can just collect this data, put it in something, press a button, and presto, you have results you can trust, right? We are not quite at that stage there. So what I'm most excited about is extremely talented folks from a bunch of different companies coming together to make that a reality. And you can see Drone Deploy is already doing this, for example, with some of their integrations today, where you don't even need to go and do any sort of setup. They have partnerships with providers that let you get RTK corrections without having to enter any credentials at all. So that is a future that I'm personally excited about. And if we have something similar that we can build and then bring to the market, which ultimately helps bring down my taxes in California, I'd be very happy about that.
I'll do my best.
Ted, you want to go next?
Sure. The one thing that I've been keeping an eye on and I'm really excited about is this notion or this concept of decentralized physical infrastructure. Accurate positioning is very important today. It's only going to become more and more important as more devices, vehicles, et cetera, rely on it. And PPK and RTK, while they're great, they still depend on this source of corrections. And for a long time, that source of corrections has been a monopoly, maybe duopoly. It's a little bit too centralized. What's sort of emerging is this concept, and I think it's probably the only use case of crypto that I've seen that I can get behind and understand the value behind it, is sort of these corrections networks hosted by individuals. For example, I run a base at my home. It's just on my roof, and all it is an antenna and a box in my basement. But every hour that base is collecting information and making it available for the network, I'm earning some coins. And I can use those coins when I'm somewhere else and I need to use someone else's base station for corrections. And this leads to sort of an incentive to just spread these bases because we need them. There's no other way to really get these corrections. You need to have observations. And as a business owner, one of the biggest pain points has been the cost of these subscriptions to get the corrections from. So we need more corrections sources. And I think this is exciting because there's an actual incentive for everyday people to set this up and then enter that network.
I also have a GeoNet box running on my roof. Oh, different decentralized network. Fight. Okay. So for me, I look at the challenge here as an engineering challenge. Whilst it is incredibly difficult and historically has been incredibly difficult to get reliable high accuracy results every single time, that is an engineering problem. That is not inherent in physical reality. And we have made huge strides, both through as you were discussing, an automatic connection to a known datum RTK network. We also do that with PPK. So if you drag and drop data into Drone Deploy, it has PPK observations alongside it. We will process that data for you completely automatically to a known datum that we know, so that we can compare it either to RTK data or to GCP data that you brought in. huge benefit here is that you shouldn't need to know exactly how to design and build a car to drive a car and get value from that car. You should be able to collect, process, and use high-accuracy data without needing to understand all of the technologies that were used to generate that high-accuracy data. And for us, really, this is about having thousands of people being able to benefit from the high-precision information and making it very, very simple. So that's the future I see, is drag and drop simplicity throughout all the value chain in this area.
All right, I guess I'm next, or last, whatever you want to say it. I was going to say that the thing that I'm actually most looking forward to is not just RTK, PPK, but actually the integration of that with dock-based UAS. I think that's what's going to fundamentally allow us to actually start to leverage our technology better. You know, when I can have dock-based UAS systems sitting out on a job site, completely autonomous, they're solar powered, they're backhauled with Starlink or 4G or 5G backhaul. I can pre-program missions into those systems and say, okay, well, again, this is future state. I can't do this because of the FAA right now. I wish I could. At least right now I can monitor it manually. But yeah, anyway, the ability to do those remote missions over and over and over again without having to have a physical person there. I mean, we have projects all over the state. We have remote portions of the state that, believe it or not, there's 2 hours where you can drive and not have a cell phone service. So for staff to be able to have to drive all the way out there to be able to do maybe a very basic routine inspection and drive all the way home. That entire way they're emitting carbon in their vehicle, unless they're driving a Tesla or something, which we're in the process of doing that too, but that's a whole nother story. Anyway, back to the dock thing. Yeah, so these remote docks, having those out on job sites, being able to do these repeat operations over and over and over again, where potentially we can back off on the physical inspection piece that I can't seem to fill those vacancies for anyway now. So we can actually still get the same level of quality that we expect out of our contractors to be producing and not have the physical staff there. That I think is really the big game changer, because if we can do that, again, tied with dock-based, the autonomy piece and then the repeatability piece with PPK, RTK, now we can actually do these, 4D, 5D simulations of how, as that contract was built over time. And if we do get a contract claim, 6 months after the fact that the contractor comes back and says, oh, you guys owe us another $1 million for, name your made-up thing, right? Okay, let's go back and we could rewind the project. We can re-digitally build that thing as it happened. So that's, like I said, I think that's the thing I'm most excited about.
That was great, and I think that sort of brings us to the part of the discussion where we open it up to the audience. I did have one final question, because I've heard this theme a little bit from you guys. It sounds like where a lot of this is going is that we're going to be creating digital twins for all kinds of different infrastructure, and in order to do that, we need drag and drop, really easy to use, high accuracy solutions. We need more robotics and remote operations so that we don't have to hire 17,000 people or fill those roles necessarily in your case to be able to do that. And then the last piece is really just some consistency around datums and the overall coordinate system that you're operating in, so that you're making sure that you have alignment across those data sets you're collecting. So it's really exciting for me to see all these things. Hopefully we'll get to that future in the next 5 or so years. But with that, let's open it up to the audience and see if anyone has any questions. I see a hand over there.
I have a question.
Oh.
Hi there. It's Jamie van Square from Dwyker Mining Services. So just listening to a lot of utility discussion this morning, but we're a mining technology platform in Africa. We challenge, and I know Ted because I watched some of those videos online, but under roof mapping, obviously it's not RTK because we're not going to have the signal, but moving into and out of these zones is probably something that we would like. Maybe just some comments from people that are doing that. I think that's quite a unique thing to be able to do GPS tonight, and then back in, again, coming back to the camera. This is probably the next discussion.
Yeah, I can take that one. Skydio fundamentally started as a vision-based company. When we first launched our product, our navigation was VPS-based, visual positioning system-based. A lot of the stuff that we do today in battlefields don't actually rely on GPS. So a core part of our history, of our engineering talent, has actually been focused around really accurate reconstructions without any of these external sources. So while you don't get the accuracy of an RTK solution indoors, I think we are pretty well positioned, and we are currently improving the photogrammetry engine that we have in order to get better and better precision. So we are always striving to improve the accuracy of our reconstructions, regardless of what the sources are. It's just a little bit harder when you don't have an RTK correction source. Yeah, question, yeah?
Just an additional thing there. You could also tie in internally surveyed targets into the situation.
Yeah, hey guys, Gary Chapman here with Turner Construction. I think we all heard you guys mention how critical accurate data will touch an array of industries, whether it's commercial, construction, safety, everyone. It really opens the doors for everything that we're talking about this conference to kind of take it to the next level. So my question is, specifically for Skydio and Drone Deploy, how much are you guys investing in accurate data within your companies, like this upcoming year? How much have you invested last year, and what's your trend? Do you see how much you'll invest in your engineers' time to make this, come to market faster, right? RTK is kind of what the industry is waiting for, with specifically the X10. So, I know everyone here is anxious to use that. So if it's so important and it changes everything and makes everything better and possible, why are we not seeing it earlier?
I'll start. It's extremely hard, is the first problem. And actually, we're working super closely with Skydio. We've got the Skydio team along the front here who are doing a bunch of hard math to make sure that this stuff's really good. I think that the challenge is if you release something too early in this space, you can lose credibility so quickly. And so you can see the diligence that the team has here, that they're trying to get to an awesome level so that when they hand it over to you, it's really, really good. From our perspective in terms of investment, it's one of two core pillars of Drone Deploy: high accuracy aerial survey, and then more and more high accuracy ground capture and survey as well, and fusing those two pieces together. It's going to continue to be one of the most valuable things, and actually we've seen in the last year a 3x increase in the amount of high accuracy data being uploaded to Drone Deploy. In construction, we're now about 35% of maps are controlled either through RTK, PPK, or GCPs, or a combination of those.
And that question was more to Skydio, right? I know Drone Deploy, you guys are heavy with accuracy, so
Yeah.
I'd love to hear what Skydio is looking to invest their engineering group on making that more available in a quicker, more rapid pace than what it's been historically.
Yeah,
Not
for
to
sure.
be so critical, but just
No, it's a new space for us. Skydio has not typically operated in the high precision market. Entering this whole DOT construction industry is pretty new for us. So we are hoping to learn a lot more from you guys, and that's part of the reason why even with the RTK Alpha, we actually came out to a bunch of construction companies trying to see what are all of the differences they have in the ways that they operate. And just the surface area there is extremely large. So that is something that we have to account for. And while accounting for that surface area and trying to hit that extremely high accuracy metric every single time, that has taken us a little bit longer than we had originally anticipated. But the engineering team is extremely well funded. So we actually had a review not that long ago, and we decided to pull more resources in to make sure that we're able to get this to market as quickly as possible. And that's kind of why I have the confidence to say today that we plan to have this before the end of this year.
awesome. Thank you.
Any final questions? All right.
Maybe to speak up. Moving beyond RTK, what do you guys have? Do you guys have any thoughts on quantum GPS? Because there's been kind of a rise in that technology in sub-millimeter accuracy that's kind of looming probably more than 5 years in the future. But what are some thoughts around that?
I don't.
those receivers sound expensive. Whenever it gets into like this measurement of accuracy, we have to remember that you either apply that to all situations or just a few select kinds. Most of the time, the hardest thing is just making sure you can compare what you've generated to a known point, and is that point accurate or not? This is a reoccurring theme whenever we get into high accuracy drone stuff, and there isn't many situations, I think, when you're using a drone, except I guess in my experience, that the precision that we see from laser scanners or total stations is really necessary. I think the drone is a tool, but those other tools will continue to exist, and it may not be GPS today or in the future. And I don't think those tools are going to go anywhere anytime soon either. And Aaron uses a lot of LiDAR. I've been using a lot of LiDAR myself. And again, like there's situations where you're going to use LiDAR, you're going to use GPS, you're going to use a drone. It really varies by the use case, I guess, or the data.
I was gonna say, I'll add to that. Yeah, I mean, we're not viewing drones as the end all be all. It's one more tool in our toolkit. We're still doing, if you're doing cadastral land work, you're doing that with a total station, you're doing that with RTK, and you're doing static sessions, right? Because that's the level of accuracy you need. It's about the standardization piece, knowing what the need is, what is the level of accuracy needed, and achieving that and no more. Because if you're doing anything more than that, you're actually wasting effort. So Ben, back to the efficiency piece. If I don't need millimeter accuracy on, midway through a project earthwork, why am I going to spend the effort to do that?
Great. Well, thank you, everyone. And let's give a round of applause for the panelists, please.
Thanks, everyone.
And a big thank you to the engineering team that's up here as well. So if you have really complex technical questions,